Okay, how did you do with the ratio and proportion questions? Here come the answers. You needed to keep your wits about you to realise whether you were doing proportion or whether you were doing ratio, okay? So I'll just read them through. Number 1A, ratio of green to black was 4:3. You always put the green first and then the black second in the order that it reads in the question. The proportion of beads was out of the whole, there's 4 out of the 7. So if there's 20 green beads, how many black beads are there? So that is looking at ratio again, and there is 15 black beads. If there are 56 beads altogether, this is back now to proportion. Out of the whole, how many are black? 24. How many are green? 32. Looking at the next recipe, it is ratio. What have you done to one side? And whatever you do to one side, you have to do to the other. Okay, so the answer was, if the quantity of dried fruit is 90 grams, then, no, what is the proportion of dried fruit? If 90 grams of nuts are used, you're going to need 135 grams of dried fruit, okay? And number 3, ice creams to ice lollies. 14 lollies was your answer for how many lollies are sold if 35 ice creams are sold. And the last one, year 4, ratio, pets, children with pets to children without pets. So if there are 36 children that don't have pets, what have you done to one side? Do it to the other to get your answer of 45 children. Hopefully you did well at that. Right, welcome back. Here we are. This is a lesson about scale, and I thought it might help you if I wrote that it was lesson 16 on the board, okay? So your lesson 16 is about scale. Your learning intention is about scale. Okay, so write that into your book or your piece of paper, and we are going to look at scale. Scale is related to ratio and proportion. It is what is used by people like architects and designers and people who draw maps, the Ordnance Survey people, in real life. This is your ratio working in real life. Okay, let's read what I've written. A map or plan is usually drawn to scale. This means the distances on a map/plan are drawn in proportion to the actual distances. So these words that are in that kind of same family of maths keep on coming up as we're looking at this area. Proportion, remember, comparing part with whole, okay? So let's break that down a little bit more to understand it a little bit more, how the proportion works in relation to the ratio and the scale. Scales are shown in 2 ways, okay? So in real life, on a plan for a house or a map, you would normally have the scale written, well, either of these 2 ways. You'd see it in either of these 2 ways, using the unit of measure, okay? So on a plan of a building extension or a new house, 1 centimetre could represent 1 metre. So for every 1 centimetre, just to there, on a piece of paper this big, okay, on the ground for the builder to start digging out the foundations, that would represent 1 metre, okay? That's in a unit of measure. As a ratio, where we're comparing part to part, 1 is equal to, or is being compared to, 1 is 100, okay? Because 1 centimetre, for every 1 centimetre, there are 100 centimetres in real life. That is the scale, okay? Let's look at how it might be represented on a map, okay? 1 centimetre on a map, like this, you fold out when you're on top of the moor going for your walk. 1 centimetre, that amount there, represents a whole lot bigger area, okay? So it is a matter, you're representing more area in a smaller scale, okay? 1 centimetre represents 1 kilometre, okay? So for every 1 centimetre on the map, there are 100,000 centimetres in the real life, in the real world, if you like, okay? Now, on questions that I've seen on SATs papers, in exercise books. This is often, this ratio, when we're looking at scale, is often referred to as scale factor. Now, a factor, of course, is a number that divides into another number. For example, 2 is a factor of 6, as is 3, as is 1, as is 6. Okay? And when we're looking at scale, a scale factor is similar but different. Okay? The scale factor means how many times it goes in. Okay? How much is it scaled up by? How much is that factor scaled up by into that? Okay? So the scale factor here is 1 to 100,000. It is the ratio. So the scale factor is the ratio that map is scaled by, okay? How many times is each one enlarged by? So here, the scale factor is 1 to 100,000, okay? So it might say in a question, 1 to 100, and that would mean that for every 1 centimetre on the plan, there are 100 centimetres on the ground, okay? Hopefully that makes sense. As we go through a few questions, you'll see it coming up, okay? Let's go through a question, actually. Here's an example. On a plan, a fence is 4.6 centimetres long, okay? So it's just small, 4.6 centimetres long, okay? The scale of the plan is for every 1 centimetre on that plan, there are 1,000 centimetres in real life. Okay, so that gardener is going to want to know how much fencing to buy. Okay, so we're going to work out how much he needs to buy. So this is like real life maths, really. So all the way through, and we've been doing ratio, we have been doing what we do to one side, we do to the other. So 1 centimetre for every 1,000 centimetres is the ratio. So 4.6 goes into this side of our ratio machine, okay? What have we done with this to make it 4.6 centimetres on the plan? We've times the 1 by 4.6, okay? So what are we going to do to find out how much fencing we need to get in real life? We're going to times the 1,000 by 4.6, okay? Right, so timesing that by 4.6 makes 4,600 centimetres. 4,600 centimetres. So that ratio has gone up in the same proportion, this side and this side, okay? So for every 4.6 centimetres, there's 4,600 centimetres in real life for that gardener to know. What, is he going to go in and say, can I have 4,600 centimetres of fencing? No, he's going to go in and say, here's metres. So what is 4,600 centimetres in metres? 100 centimetres to a metre. So we divide that by 100. There is 46 metres of fencing needed. Okay? So that is what we needed to find out. Let us have a look at a couple more problems, then I'll set you some to do for tomorrow. Okay, let's work through these 3 examples together. Right, so number 1, this is in units of measure. For every 1 centimetre on the plan is going to be equal to 1 metre. So let's write that as a ratio so we can see what we've got to do. So for every 1 centimetre, there's 1 metre. So let's get into the same unit of measure so we can compare. So how many centimetres in a metre? It's 1 to 100. Comparing part to part, 1 is equal to 100. Okay, for every 1, there are 100 in real life. So let's measure how many 1s we've got in this line. We have got 10.5. 10.5 lots of 1. Okay, so we put that on that side. Okay, so how much is that going to be in real life? What have we done with the 1 to make it 10.5? We've made it 10.5 times bigger, okay? So we've times it by 10.5. So that's what we need to do on this side to work out how long that line is in real life, okay? So 10.5, 100 times bigger, is of course 1050 centimetres. Okay, so that will be the answer to that. So that's 1.05 metres. Agreed? Next one, let's have a look. Again, this is in units of measure. Slightly more difficult this time, okay. 1 centimetre to 1 kilometre, okay. So there's 100 centimetres in a metre and there's 1,000 metres in a kilometre, isn't there? So 1 centimetre in, so this is like a map almost, isn't it? 1 centimetre on the map equals how many centimetres in real life? Okay, so 100 times 1,000 is 100 times 1,000 is 100,000, of course. So for every 1 centimetre on the map, there's 100,000 centimetres in real life. Let's see if we can find out what scale this should be in real life then. So that is 11 centimetres long. Okay, so the 11 centimetres on the map is equal to what in real life? What have we done with the 1 to make it 11? We've times it by 11, haven't we? So that's what we need to do in real life. So it would be 1,100,000, wouldn't it? Centimetres in real life. Wow, okay. So the last one. So this is just written as a ratio already. So for every 1 centimetre, it equals 10,000. Okay, 10. Well, actually we don't. Well, it is centimetres because we're going to measure it in centimetres. So for every 1 centimetre equals 10,000 metres, maybe, or 10,000 kilometres. We don't know. It doesn't say. But we'll measure it in centimetres anyway. Okay. So that is 4 centimetres. So let's write this down here, okay? So 1 to 10,000. So we put a 4 in this side. We've times it by 4, made it 4 times bigger. So therefore it's going to be 10,000 times bigger in real life. So times it by 4 on this side, times it by 4 on this side. So that is going to be 40,000. Whatever's really, it could be metres, it could be kilometres, but we've just kept it in the same ratio, okay? So that is the right answer for that one. Right, I'm going to leave you for a second, reset the board, and then I'll leave you to do those for tomorrow. Right, so here are the problems to solve for tomorrow. We have got a floor plan here, not drawn to scale. I might add very, very quickly because I'm drawing it on a board. Quite tricky to do. Okay, this is the floor plan of a 2-bedroom bungalow. All these lengths are in metres, 3.4 metres, 3.2 metres, etc, etc. Copy the plan using the scale, okay? Not the scales, just the scale. Okay, so the scale is 1 to 100, okay? That is the ratio. So for every 1 that you measure out in real life, it equals 100. So let's have a look, think about that. Let's make it so the scale is for every 1 centimetre, you have 100 centimetres in real life, okay? So 3.4 here. Let's have a little think about it. You're going to draw this scale in your book, this plan in your book to scale. Draw to scale. That's direction number 1. So let's work out how you're going to do that, okay? So if it says 3.4 centimetres, if it says 3.4 metres in here because all the lengths are in metres, you draw it. You draw it 3.4 centimetres long, don't you, okay? Because 3.4 metres divided, 3.4 metres in centimetres is 3.4 centimetres, yeah? Okay, because you divided it by 100, okay? So you copy it to scale and then you write the real life measurements in metres, okay? Onto your scale. So 1 centimetre, so 3.4 centimetres would equal 100 centimetres in real life. So you draw it like that. Okay, I will look at it with you tomorrow. Make sure that you like, subscribe and turn on post notifications.